is an equation with one or more rational expressions. A rational equation is an equation with one or more rational expressions. So when you think of a rational expression, you think of a fraction, a polynomial over a polynomial. Polynomial, that's polynomial divided by polynomial. So if you go back to number 2, the one we just did, this one here, number 2, the original problem. We know that it's linear, right? But this is also a rational equation. Because remember, a rational equation is an equation that has one or more rational expressions. And if you look at all these are all fractions. Just think of fractions. Really, though, it's a polynomial divided by polynomial. Remember, a polynomial is one or more monomials, one or more terms. So even though you see one thing there in the denominator, it's still called a polynomial. So these are all rational expressions. So number 2, even though it's linear, it's still considered a what? Rational equation. Number 1, this is also a what? Rational equation. Number 2 up here, even though you don't see any fractions, it is still a what? Right here. Rational equation, because 16, you can say 16 divided by what? 1. It's a fraction. 3 times x minus 1 divided by 1. X minus 7 divided by 1. So everything we've done so far, even though we said they were linear, they're also what? Rational equations. But not all rational equations. Is this a rational equation? Is this a rational equation? Yes, because it contains one or more what? Rational expressions. But is this rational equation linear?
Yes.
The answer is no. It is not. Because remember, a linear equation cannot have the variables located where? In the denominator. So numbers 1, so the 4 problems we've done, if you go back over those 4 problems, were any of those denominators, did any of them contain variables? No, they contained numbers. The variables are located in the numerator only. So this is not linear because the variables are located in the denominator. Even though you see x to the first, it's in the denominator. So it's not a linear equation. It is a rational equation. So here's the question, and they have some form of it in my math lab. Are all linear equations rational? Yes. We just talked about that. The 4 problems we did. Are all these linear equations out here, did we said they were all what? Rational. Are all rational equations linear? No, that's not. Some are. This rational equation is what? Linear. This rational equation is what? Not linear. All right. But when we did number 2 here, what was the first step we had to do? Find the LCD. Because I had a fraction, right? I had to clear the denominator. I have to do the same thing here. I have to find the LCD. Now they're going to take you to what you learned last semester also, in terms of finding the LCD. Finding the LCD when there's just numbers in it is easy. Finding the LCD when there are variables in it is not as easy, but you had the practice last semester. When finding the LCD that involves variables, you have to factor first. So step one will be to factor your denominators. Now, last semester, some of you got to this point, some of you did not, depending on how far you got. Sometimes I get to it, sometimes I don't. Last semester, I didn't get to this point. The semester before that, I did.
Yeah, but I forgot all that.
So we'll spend a little bit more time on that. So that's why I'm going to do a sum here tonight and then some tomorrow night. Okay, so if you look at your denominator, these are considered monomials. Because how many terms do you see? One. This is a monomial. What is this denominator right here? One. It's a monomial. When they're monomials, it's easy to determine the LCD. The LCD must include every factor you see. Every factor. Must include every factor. So if you look at that first monomial, that's 1 times x, right? Or just x. So since that's an x, it must be part of the LCD. Because remember, the whole point of multiplying by the LCD is to make this right here what number? A 1. Well, in order for that to be a 1, whatever I put here, 3 has to go into it, right? It has to reduce. So if I want to make this a 1, that means I got to multiply by what? X. So x has to be part of the LCD. So it's easy to see it that way. If I want this to be a 1 right here, since I'm dividing by x, I've got to now do what? Multiply by x. So that has to be your LCD. Now let's go to the next fraction. There's an x, right? I already took care of it. You see it here. But what else do I need in there? A 2. So I also need a 2. What's this number right here? 1. 1 goes into everything. So what's the LCD? 2x. There's your LCD. Now, before we go on, we also need to talk about restrictions. Okay, restrictions. So remember, in all the courses you've had in the past, you can never divide by what number? 0. You can never divide by 0. So one of the things you talked about last semester, and in my course we did get to that point, if I have this rational expression, and let's say it was this, 4 divided by x minus 8. 4 divided by x minus 8. That's a rational expression because you see a fraction, right? What can't x be? No. Your denominator can't be 0, but you didn't answer my question. What can't x be? 8.
Oh, okay.
X can't be 8. Because 8 minus 8 is what? 0. So your restriction is that x cannot equal what? 8. I can let 8 be any other number. Someone said 12. I can let x be 12, right? I will get 4 divided by what? 4. That's okay. 4 divided by 4 is 1. I just can't let x be 8. All right. Now, knowing that, let's go back to this one now. What makes this denominator right here 0? No, but you're trying to find what x is. What makes this denominator 0 when x is what? 0. Now, don't confuse that with this. Some of you said x can't be 0. X can be 0 here, because what's 0 minus 8? A negative 8. You're looking at the expression, the denominator. So x cannot equal 0 here. What can't x be here? 0, because 2 times 0 is what? 0. So how many restrictions are there? There's just one. So you're going to say x and that equal what? 0. All right, now that's going to be important because there are going to be some problems for these rational equations where your solution is a restriction. And then we're going to end up bringing another word here called extraneous root. I'll talk about that when we get to that point. But that all has to do with your restrictions. All right, so notice when we did these, did I say anything about what are the restrictions? No. But these are rational equations, right? Why is it that I didn't say anything about restrictions here? They didn't have a variable, the denominator. Is this denominator ever going to be 0? No, it's always going to be what? 3. Is this denominator right here ever going to be 0? No, it's what? 1. This denominator is what? 2. This denominator is 6. Is this denominator ever going to be 0? Yes, when x is what? 0. Is this denominator ever going to be 0? Yes, when x is what? 8. All right, once you find your LCD, everything else is like you did this. So what's the next step? Multiply both sides by 2x. All right, so I'm going to rewrite it over just like this. Am I going to put any of this in parentheses? Which side? The right-hand side. I'm going to say times 2x times 2x, just like this. All right, I compare this with what we've done before. What's the next step? Distribute the 2x here. So I get 2x times 4 divided by x equals 2x times 5 divided by what? 2x plus 2x times what? 3. All right, so that's where I'm at. So all I did was use the distributive property. Now, if you think about what we did in the previous 4 problems, or some of them at least, what is that next step that I'm going to do now? What did I say what we're going to do? What's that called? Reduce. Reduce. Okay, so the whole point of multiplying by the LCD is to make these denominators what numbers? 1. X into x is 1. X into x is 1. 2 into 2 is 1. 2 into 2 is 1. X into x is 1. X into x is what? 1. And that's all I got to do, right? Now, what's 2 times 1 times 4? 8. Equal. What's 1 times 1 times 5? 5. Plus, what's 2x times 3? 6x. So there's where I'm at. So I went from something that looks complicated to now notice I went from a rational equation to what kind of equation? Linear. This one's linear. Okay, so you see, I went from something that looked complicated to something that's now easy to deal with. What's the next step? There's no terms that are alike on either side. Subtract 5 from both sides. Now combine like terms with 8, subtract 5. Equal 6x. Finally, divide by 6. Reduce. I get x to be what? 1/2. Is that a restriction? No. So that's my solution. If it was a restriction, and that's the only thing you got, you would say no solution. We'll get to that point in a little while. All right, so don't worry about that just yet. So there's your solution. It's not your restriction, so you're good. That's your solution. All right, so notice the first thing you're going to do, the monomials are easy. See how this rational equation, the denominators were monomials? That's the easiest to deal with to find the LCD. And then once you find the LCD, the rest is like you did before. Just multiply both sides by the LCD. All right, let's look at this one. That's number 2. So let's call this number 1. And this is going to be number 2. All right, number 2. Suppose we had this one. X minus 1 divided by 2x minus 2/3 equals 3 divided by x minus 1. X minus 1 divided by 2x minus 2/3 equals 3x minus 1. Okay, listen to my question first. Is this a linear equation? No. Because what do you see in the denominators? Variables. But is it a rational equation? Yes. Since it does have variables in the denominator, let's find the restrictions first. What can't x be? Yeah, x cannot be 0. When it's a monomial, it's easy to determine what the restriction is. Because if x is 0, what's 2 times 0? And you cannot divide by 0. Is this right here ever going to be 0 that I'm pointing to? No. Will this be 0? When? It could be when my denominator is what? 0. So in both cases right here, you see the ones I'm pointing to that have the variables? They have the same restriction. What's the restriction? Cannot be 0. So how many restrictions are there altogether? 1. We're going to do one in a little while. Actually, it'll be tomorrow, where the restriction is something other than 0. But for right now, it's just 0. Now, this is the easy kind because your denominators are monomials. What's the LCD now? 6x. Good. When finding the LCD, every factor has to be part of your LCD. So if you look at 2x, if I want this to be a 1 right here, then I've got to multiply by what? 2x. So 2x has to be part of the LCD. If I want this to be a 1, then I've got to multiply this by what? 3. But 3 will not go to 2x, so I've got to say times what? 3. If I want this to be a 1, then I've got to multiply by what? X. Do you see an x in here? Yes. And this is already a what down here? A 1 and 1 goes into everything. So what's the LCD? 6x. Once you find the LCD, what's the next step? Just like you've done before. Multiply both sides by the LCD. Put parentheses on both sides. Very good. All right. So all I did at this point was just rewrote both sides and put them in parentheses because on both sides they had more than one fraction. So you can say times 6x times 6x. Now, based on all the problems we've done, what's the next step? Distributive property. In both cases, you can distribute as 6x. So you can say 6x times x minus 1, and you're going to put that in parentheses, very good, divided by what? 2x. Minus 6x times what? 2/3, just like this. Equal? Now on this side, you're going to say 6x times what? 3 over x. Minus 6x times what? I already have that minus right here, so you can just say what? Times 1. Okay, so I only really needed to put the first fraction, the numerator, the first fraction in parentheses. Okay, now, remember the next step at this point, remember we said all the time was to reduce now. Because remember the whole point of multiplying by the LCD is to make these denominators what numbers? 1. 2 into 2 is 1. 2 into 6 is 3. X into x is 1. X into x is 1. 3 into 3 is 1. 3 into 6 is 2. X into x is 1. X into x is 1. And that's about all I can do, right? Now let's go ahead and rewrite what I have. Notice what I'm pointing to. 3 times 1 is 3. So that's 3 times, in parentheses, what? X minus 1. That's what this is right here. Minus 2 times x times what? 2 is what? 4x. Very good. Equal 6 times 1 times 3 is 18, minus 6 times x times 1 is 6x. That's where I'm at. So I went from a rational equation that looked complicated to a rational equation that's not as complicated anymore. What's the next step? Distributive property on that first parentheses. This is 3x minus 3 minus 4x equal 18 minus 6x. What's the next step? Combine like terms. And so what's 3x minus 4x? So that's negative x minus 3, right? Equal 18 minus 6x. All right, so that's where I'm at. All right, so let's do now. Notice this is a linear right here. So let's bring the variable to one side, constant to the other. What do you want to do first?
Add 6x.
Add 6x, okay. What's a negative 1x and a positive 6x?
5x
What else?
minus 3.
Equal 18. All right, so that's where we're at. What's the next step?
Add 3.
Okay. Combine like terms. What do you get?
5x equals 21.
All right. And then I'm just going to write this over. Divide by 5. So what's your solution? 21 fifths. All right. Is that a restriction? No. So that's your solution. So notice though, all these are equivalent equations. So solutions here, the solution to all these. Now, if it was a restriction, if this happened to be a restriction, we would have to discuss something else. And at this point, we don't have to worry about that. You would say no solution. Okay, so if you look at that worksheet now, part 2, look at part 2. You can now do which one? Number 2, and I think that's it, right? Yep. So now you can number 2. Okay.